Hi, today we are going to see the root locus with complex poles in lecture 7 control system, and this is Penila. So we are going to see the step-by-step procedure how to solve the root locus with complex poles as well as zero. A unity feedback control system has an open loop transfer function g of s is equal to k into s plus 9 divided by s into s square plus 4s plus 11. Sketch the root locus. So the procedure is, the step 1 is to locate the poles and zeros of g of s into h of s on the s plane. So here h of s is 1 because of unity feedback system. So g of s is equal to this one. So if you equate the polynomial of the numerator to 0, the roots will give you the zeros. The polynomial of the denominator is equated to 0 and the roots will give the poles here. So s plus 9 is equal to 0. So zeros is going to be 1, that is minus 9. And then s into s square plus 4s plus 11. So if you equate it to 0, so s is equal to 0. So 0, and then this s square plus 4s plus 11 will give you the roots as minus 2 plus or minus j 2.64. So total it has 3 poles and then 1 zeros. So you can either use the calculator or the formula method to solve, to get the roots. So I have plotted the zeros. So 0 should be plotted as a bubble, and then the poles 0, and then this is minus 2 plus 2.64j and minus 2 minus 2.64j. So 3 poles and 1 zeros have been plotted. Next step 2 is to determine the root locus on real axis. So take a test point on the real axis and verify the number of poles and zeros on the right side. So if it is going to be odd number, then you will have the root locus. If it is going to be even number, then there is no possibility of root locus in that area. So this is how we are going to consider only the real axis. So here I have one pole as well as 1 zero. So in between the 0 and then this pole, that is your 0 and minus 9, I will be taking one test point. So let it be minus 4. So the right side of my test point, how many poles and zeros are there in the real axis? So it's going to be only 1. So we will have root locus in between 0 and then the minus 9. So after minus 9, I will be taking a test point. So let it be anywhere else minus 9.5 or something else. You will be having 1 0 1 4. So totally it is 2. So you will not have any test point between the region minus 9 to your minus infinite. So the portion of real axis from 0 to minus 9 will be a part of root locus. So step 3 is to determine the asymptotes of root locus branches and then meeting point of asymptotes with the real axis, that is called as a centroid. So the formula is plus or minus 180 degree divided by 2q plus 1 divided by n minus m. So q is given by 0, 1, 2, 3 up to n minus m. So you know very well, n is going to be the number of poles, m is going to be number of zeros, right? So here we have 3 poles as well as 1 zeros. So n minus m is going to be 3 minus 1 is going to be 2. So q is equal to 0, 1 and 2. Now I am just substituting the value of q as 0, 1 and 2. I will be finding the angle of asymptotes. If I substitute q as 0, 180 divided by 3 minus 1 is going to be 2. 180 divided by 2 is going to be 90 degree. If I substitute q is equal to 1, so 2 plus 1 is 3. So 180 into 3 divided by 2. So you get plus or minus 270. And if I substitute q is equal to 2, so 4 plus 1 is 5. 5 divided by it's going to be 5 divided by 2 into 180. It's going to be 450. So if it is less than 180 degree, you will have the original angles. All other greater than 180 is repetition of the previous angles here. So it's going to be plus or minus 90. So a centroid is given by sum of poles minus sum of zeros divided by n minus n. So sum of poles is nothing but 0 minus 2 plus 2.64j minus 2 minus 2.64j, and then zeros is going to be your 9. So this is going to be the 1. So divided by 3.1, 3 minus 1 is going to be 5 by 2, which is equal to 2.5. So here the value is going to be minus 2 is going to be minus 4, and then this is going to be minus of minus 9. So your zeros is going to be minus 9. So minus of minus 9 is going to be plus 9. So plus 9 minus 4 is going to be plus 5 divided by 2 is 2.5. So the centroid is going to be 2.5 and then plus or minus 90 degree. I have drawn the asymptotes. So next is to find the breakaway and breaking point. So here breakaway and breaking point, it has neither breakaway nor breaking point as you don't have adjacent poles or zeros here. So step 5 is to find the angle of departure and angle of arrival. So here angle of departure is exists because we have complex pole. Angle of arrival doesn't exist because we don't have complex zero. So angle of departure from a complex pole is 90 degree minus sum of angles of vector to the complex pole A from all other poles, then from all other zeros here. And this is the graph we have. This is going to be your real pole, this is going to be the real zero, and this is going to be complex pole and then complex pole. So we will be taking one as a reference here. So this let it be is going to be your A, and then I am just going to have this as a reference pole. So we have to take a complex pole as reference here. Now we have to connect this complex pole, reference complex pole to all other poles here. First we will concentrate the poles here. So I have two poles. So from this one to this reference pole I will connect, right? And then this is going to be another one. So I can have this as a I can connect this to the next one. So I have connected here. So I have connected the reference pole to all of the four poles here. Okay. So let the angle be theta 1. So this be your theta 1 and then this be your theta 2. So this is going to be the reference rate. So this is going to be your theta 2. So now I am just connecting the zeros to the reference pole, right? So complex pole. So from zeros I will be connecting to the reference complex pole, and this angle will be your theta 3. So now we have to find the theta 1, theta 2 and theta 3. So theta 1, so this is going to be your obtuse angle. So it's my 180 degree minus tan inverse of B by A. Actually B is going to be the imaginary part. So this imaginary part, this length is going to be 2.64 and then this is going to be your A, because we are bothered about only this triangle here. So this is going to be the length, which is nothing but 2 here. So 2 in tan inverse of 2.64 divided by 2 is going to be 127.1 degree here. And then this theta 2 is going to be 90 degree. So this is the right angle, so it's 90 degree here. And theta 3 is an acute angle. So it's going to be formula is tan inverse of B by A. So here this is going to be your tan B is going to be 2.64 and this is going to be your A. So from minus 2 to minus 9, the value is going to be 7. So this is minus 2 to minus 7. So this is going to be your A value here, right? Because we are bothered about only this triangle. So the A value is going to be minus 2 to minus 9, which is going to be 7. So tan inverse of 2.64 divided by 7 is 20.7 degree. So the formula is 180 degree minus of theta 1 plus theta 2 plus theta 3. So the total angle is going to be, angle of departure is going to be minus 16.4 degree. So I will be drawing this minus 16.4 degree here as well as here. In both the complex poles I have drawn the 16.4 degree here. Step 6 is to find the points where the root locus crosses the imaginary axis. So the characteristics equation is s cube plus 4s square plus 11s plus k into s plus 9 is equal to 0 here. So s cube plus 4s square plus 11s plus ks plus 9k. So this ks and 11s, so I just take your s out. So 11 plus k s plus 9k. So replace your ss by j omega. So I replace the j omega here. Now I equate the real part and then imaginary part to 0 here, right? So j cube is nothing but minus j and j square is going to be minus 1. So equate the real part, the imaginary part. So minus j omega cube and then 11 plus k j omega equal to 0. So take this one to this side. So now I can cancel this j, and then this omega, and then this is going to be your square. So now your omega square is equal to 11 plus k. So here the k value, how to find the k value is, I will just equate the real part, that is minus 4 omega square, and then plus 9k equal to 0. So I will be taking this 4 omega this side, and then what is your omega square? Omega square is going to be your plus 11 plus k. So replace your omega square as 11 plus k, and then it becomes 44 plus 4k. And then I can take this minus 4k to this side. So 9k minus 4k is going to be 5k, which is equal to 44. K is 8.8. So I will replace the k as 8.8 here. So it's going to be 19.8 omega square. Take the square root, it's going to be plus or minus 4.4. So the crossing point of the root locus is 4.4 and the k value is 8.8. So I have plotted this 4.4, here 4.4, and then you just connect the angle of departure to this point, and then here from this point angle of departure to this imaginary axis. Thank you guys. Subscribe my channel for automatic update. Have a nice day.